This question is from K 2014 Mechanical Engineering paper, Set 4, question number 32. For the truss shown in the figure, the forces F1 and F2 are 9 kN and 3 kN respectively. The force in kilonewton in the member QS is. Let's find out. Forces are in kilonewton that we have shown here. So, as the external force is on joint P and joint Q, we can either take joint P or joint Q to draw joint free body diagram and eventually find out QS. Now at joint Q, we see that there are 1, 2, 3, 4 members connected and forces in all these members are unknown. So we will not be able to solve it using the equilibrium equations. Instead, if we choose joint P, we can see that there are only 2 forces that are unknown. Force in member PQ and then force in member PS. So we can choose joint P first. Once we choose joint P, we need to reach to member QS. In order to reach to member QS, we cannot take Q again because more number of unknowns. So we will take S instead. When we take S, we have again 2 unknowns here, force in QS and force in ST. As force in PS, we can already find out from the step 1. So let's do it. In step 1, we take joint P. Force on this joint are 9 kN external force and force in member PQ. Let's assume the forces to be away from the joint first. This is force in PQ, FPQ, and force in PS, FPS. Now our aim is to find out only force in PS because we don't require PQ. We are going to then choose joint S. So to find FPS, we'll first have to find out this angle. In this figure, we can see that this much distance, if we draw this vertical line, this much distance is 1.5 meter. It is already given 1.5 meter. So in this triangle, we can find out this angle by doing tan inverse of opposite side upon adjacent side. Opposite side is 2 meter, adjacent side is 1.5 meter. So this angle, let this be theta, is nothing but tan inverse 2 by 1.5. This we can calculate in digital calculator. It gives 53.13. We can take it as 53 degree. Now we found out this angle to be 53 degree. Which equilibrium equation should we choose in order to bring in picture FPS alone? It's the vertical equilibrium equation. Therefore, we will use by summation Fy here for joint P. We have at joint P, we have summation Fy gives us 9 kN is downward, so we will take minus 9. Vertical component of FPS will also be downward, so it will be minus FPS cos of 53 degree is equal to 0. From here we get the force in member PS will be equal to minus 9 by cos 53 degree. This turns out to be minus 11.27 kN. So because we have got a negative sign here, it clearly indicates the direction we assumed was wrong and actually the force is in opposite direction. So the force is towards joint P. This is nothing but force in member PS, which is 11.27 kN. Now next we'll choose joint S. So at joint S we can see here forces that are applicable are FST, force in member ST, force in member QS, which we need to actually find out, and force in member PS, which we already found out as 11.27. But be careful while marking the force because FPS is towards joint P. It is compressive. So to mark compressive force, we will mark it towards the joint. That is towards S. So this is nothing but FPS. Now again, we need to find out force in QS. So choose an equilibrium equation such that it should involve only the vertical forces so that FST will not come into picture. Now as far as angles are concerned, this angle we already know it is 53 degree. These two triangles being antisymmetric, we know this angle is also 53 degree. We can check with the dimensions also. This is 1.5, this is 2. Again it becomes tan inverse 2 by 1.5. So it is 53 degree. Now taking summation Fy equal to 0 at S, at joint S, we have vertical component of FPS will be downward. So it is minus FPS sine 53 degree. It is not cos 53 degree this time because we are taking this angle. So it is actually the sine component plus FQS again we have assumed to be away from the joint. So the vertical component of FQS is plus FQS sine 53 degree again is equal to 0. Simply we can take sine 53 degree common and this goes to the right hand side, becomes 0. So FQS is simply 11.27 kilonewton, which is equal to the force in member PS. But here is the most important point, that we have got a positive sign for force in QS, which means that the direction that we assumed for QS is correct, and therefore force in QS is not having the same nature as force in PS. Although the values they have are equal, their nature is opposite. Getting a positive sign means the direction that we assumed is correct, and therefore FQS is away from the joint, which means it is tensile. 11.27 kilonewton tensile force is the force in member QS. Let's go back and mark the correct option. It's given in option A, not 11.27 but nearly equal, 11.25 kilonewton, which is tensile. To learn more about analysis of trusses, you can refer to the NPTEL video, Lecture 8, Trusses 2, from the course Engineering Mechanics. This course is by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.